Okay, so finally for this lesson, let's review over the hypothesis test procedure. So the steps to hypothesis tests are summarized here. The first step we do is always frame the research question in terms of hypotheses. One of the hypotheses is called the null hypothesis, which is the random chance hypothesis. The other is the alternative hypothesis, which is the researcher's hypothesis. From there, we would collect data with either an observational study or an experiment. And for our class, that will usually be done for you. We will analyze the data, where we figure out the point estimate and p-value. And based on those results, we'll form a conclusion. Are we going to reject the null hypothesis or fail to reject it? So, again, we first start off frame the research question in terms of hypotheses. Hypothesis tests are appropriate for research questions that can be summarized in terms of two competing claims. The null hypothesis, H0, usually represents a skeptical perspective or a perspective of no difference. This is the random chance hypothesis. The alternative hypothesis usually represents a new view or a difference. From there, we would collect the data with an observational study or an experiment. If the research question focuses on associations between variables, but you're not really concerned about causation, then you could run an observational study. If you're interested in seeking a causal connection between two or more variables, then an experiment should be used. From there, analyze the data. Choose an analysis technique appropriate for the data and identify the p-value. Right now, we've only seen one technique, and that's randomization and simulations. Throughout the rest of this course, we'll encounter several new methods suitable for other contexts. And then from there, we'll form a conclusion. Using the p-value from the analysis, we'll determine whether the data provides statistically significant evidence against the null hypothesis. That is, in terms of statistically significant, that basically means, can we rule out random chance? If we reject the null hypothesis, we're saying that random chance is not the likely explanation. If we fail to reject the null hypothesis, we're saying that random chance is plausible, so we should keep the null hypothesis until we have more evidence. So, form your conclusion, and also be sure to write a conclusion in plain language so casual readers can understand the results. So they're saying here, if the p is low, the null must go. If the p is high, the null will fly. So if the p is low, p-value is low, you're going to reject the null hypothesis. If the p-value is high, more than 0.05, then the null hypothesis is plausible.